Hello everyone, I'm here to help. So now we want to answer question 5 of the 2023 paper 1. It's a relatively simple question. There's not much thinking to do. If you've done this question enough, if you've done this type of question enough times, this is just a breeze through. So the first thing we're going to do is just look at the functions that we have with f of x, which is a parabola, and you can see it's inverted there. There's a negative, and so it goes that way. And then with g of x, which is just a straight line. The first question, 5.1, is write down the coordinates of the turning point of f. The turning point occurs here. That's where the turning point occurs. That's what they mean by the turning point of f. So we're looking for the coordinates of this point. And note that they say coordinates. So make sure not to just give them the value of x or just the value of y. You want to give them the coordinates, both of the coordinates, the x and y coordinates. So we'll start with question 5.1. The first thing that I want to do is copy f of x, the function f of x, and just simplify it as well for easier manipulation throughout the question. We have x plus 3 all squared plus 4. And simplify this, you have negative x squared minus 6x minus 9 plus 4. That gives us a negative x squared minus 6 minus 6x minus 5. If you're wondering how I was able to simplify this so easily, any function that is of the form, I'll just name this g of x. No, there's already a g of x, so I'll name this h of x. Any function that is of the form ax plus b all squared, when simplified, becomes ax all squared plus 2abx plus b squared. That's how you simplify it. So in this case, the simple is just x squared, 2 times x times 3, that's 6x, 3 squared, that's 9. Then you remember that you have a negative that was factored out here. Then you just bring that in. Now we have negative x squared minus 6x minus 9 plus 4. Simplify that, you get f of x is equal to that. Now let's just copy this and continue. The easiest way of finding the turning point of a function is through differentiation. Now some of you maybe might not be aware or know how to differentiate properly, so I'll just remind you guys or teach you if this is your first time. The easiest way, most of the functions that you get are of this form. The easiest form of differentiation that occurs is this one, ax to the n. Say this is function f of x. The derivative of this, dy dx, that is of course if this function is also named y, which in most cases is, dy dx, or f prime of x, the derivative of the function is equal to a n, what's on top here, multiplied by the constant whatever is here, x n to the xn minus 1. So this is the easiest form of differentiation that you will encounter, and it's very common. So what you want to do now is differentiate this function. If you need to recap on your differentiation, you can go ahead, pause the video and just go through some differentiation, but this is as simple as it gets. This is the simplest way you would want to differentiate something. Now let's differentiate this. It becomes minus 2x minus 6. The derivative of a constant is always 0. If you think about it, it's 5x to the 0. So you just take this 0, you multiply it here using this rule. You realize that the outcome of that is 0. Now we simplify this. Oh, it's already simplified. Now what you need to know about the derivative of a function is that at this point is that the derivative of a function tells you the gradient of the function at every point within the domain of the function. So when I say domain, just a reminder as well, domain is the input. The domain contains the input values of the function. The range contains the output values of the function. So what we have here is that our domain, as you can see, is from minus infinity to infinity. That's the domain that we have. Any value of x can be put into our function and the output of the function will still be a valid real number. So now, as I was saying, the derivative of a function tells you the gradient of the function at any point within the domain of the function. So if you put if you input this value of x at this point, it will give you this gradient. If you input this value of x at this point, it will give you this gradient. And what you will note is that at this point, the gradient of the function f is 0. The change in y, the instantaneous change in y just at that point is 0, because that's what the derivative means. Dy dx, that means, or can be approximated as the change in y over the change in x. That's what it means. Now, as you can see that the derivative here is 0, now you can equate this function f prime of x to 0. Minus 2, 0 is equal to minus 2 x minus 6, and where you evaluate this becomes minus 3. So now you have the value of x here at the turning point. As you can see, there's not a lot of work to do here. It's just step 1. Well, of course, there's a bit of simplification at the top, but step 1, step 2, step 3, step 4, you're done. It's over. Then the next thing you want to do is get the y coordinate, because as I said in the beginning, they're looking for the coordinates. So this here is not a complete answer. It's not a complete answer. What you want to give them is a coordinate. How do you get the coordinate? You have the x value now. Now you're looking for the y value. So y, which is also equal to the function f of x, is given as minus 2 minus x squared minus 6x minus 5. Now substitute minus 3 into the equation. What you have then for y will be minus 3 squared minus 6 minus 3 minus 5. And when you evaluate that, becomes 4. You can go over the grade 1 algebra there, but then yeah, that's the value that you should be looking for, 4. Then your answer, because they're looking for coordinates, should be intersection. No, it's not the intersection, turning point. Turning point occurs at x coordinate first, y coordinate second. Remember this, x coordinate first, y coordinate second. That's how you write coordinates, with a comma in between. That's your answer. Now we can move on to question 5.2. I'll just clear this up for some space and just keep the answer. You can always go back to rewind the video and check what you missed. I'm just going to keep the answer and we move on to question 5.2. It's a really simple question. Question 5.2 goes, write down the range of f. As I said, the range contains the output values. If I were to put any value of x into the function, what values of y am I expecting to get? As you can see from the function that we have here, it's pretty obvious from the function, because the function is parabolic, meaning it will only have one global maxima or global minima. But also, you could take that from our derivative. Remember, our derivative was, let me just write that, rewrite it here. F prime of x was minus 2x minus 6. As you can see, our derivative will always be negative. What does that mean? What does that tell us? It tells us that the gradient of the function will always be negative, meaning the function is always going to go down. It will never come back up. Therefore, we'll only have one global minima. So it's easy to tell what the range of the function will be. So we know that the turning point occurs at y is equal to minus 4. Is equal to 4, I mean. There's a 4 there. And the function continues going down for the foreseeable future. So our range, therefore, will be equal to, and you want to write this in set notation, or yes, we want to go from minus infinity to 4. Note that I have used different types of brackets on both sides. This bracket here, the curly, the semicircular one, well, yeah, the semicircular one means exclusive, I mean, exclusive. And this square bracket here means inclusive. What that means is, at infinity, our function never really gets to infinity. Infinity is not a number you can manipulate algebraically like any other natural or real number. 4, on the other hand, is a real number which the function actually gets to. F of x gets to 4. So therefore, our range is from minus infinity to 4. That's our range. That's question 5.2. Simple and straightforward. Don't have to calculate anything there. Just have to observe and think and write down the answer. It's only worth 1 mark. Show that the coordinates of A and B are minus 5 and minus 2 respectively. So we know that our x coordinates here is minus 3. So when they say A is minus 5, it sort of makes sense. You can, I can see that being minus 5, and B is minus 2, and also makes sense. You can see, I can sort of see that being minus 2. So how do we get these values? How do we show them that these values are minus 5 and minus 2? So we know that these functions intersect at A and B, functions f of x and function g of x. So when they intersect, we can equate those two functions. So what I'll do is equate the simplified version of f of x and g of x, and just take those down to solve. Minus x squared minus 6x minus 5. This should be equal to, at A and B, it should be equal to x plus 5. I'll just copy this and we go and solve. Should be not much of a challenge to solve. Now, how do we solve this? The easiest thing here would be to move everything on this side and carry it over to this side so that it becomes positive. Well, I say move, but if you want to be pedantic about it, you actually adding x squared plus 6x plus 5 on both sides of the equation, and you'll see that this here evaluates to 0. Therefore, you can continue with the solution. Becomes x squared plus 7x plus 10. This should be equal to 0. Now you want to factorize this. The easiest way to factorize this I have seen over the years is looking for the sum and product of these values. Call it sum product. You're looking for two numbers that will give you a sum of 7 and a product of 10. Of course, you can, in a way, cheat the system. How do you cheat the system? You cheat the system by looking at the values that they've given you, -5 and -2, and working towards those values because you know those values are correct. And as you can see, 5 plus 2 is 7, 5 times 2 is 10. You've cheated the system. You already know the values that you're looking for. As I say, though, that's cheating the system. But you can, I'd like to think of it more as working smart, because there's no need to think too much about it. However, the roundabout way of going through this would be to multiply 7 and 10. That's 7 times 10. That gives you 70, and writing down all the factors of 70. Factors of 70. Those are 1, 2, 3 is not a factor, 5, 7 of course, 10, and then there's 35 and 70. I'm not sure if I missed some factors, but I think those are the factors. And then looking at the factors that you have and looking for the sum product, sum of 7 and product of 10. And as you can see from this, that 2 and 5 are the only values that match what you're looking for. So now you can just write down the factors. Plus 2, x plus 5, this should be equal to 0. X is equal to -2, x is equal to -5. Now you've shown that the factors, you've shown that the intersection occurs at -2 and -5 by solving the equation that occurs when you equate the expressions of the functions f of x and g of x. So that's that. Very simple. I'll just clear this up as well to leave some space for the next question. Just leave the answer. Take this, put it there. Okay. Now 5.4 quickly. Hence, now when you see hence, it always means because you've solved whatever you've solved in the previous questions, because you know the answers to the previous questions, then answer this question. As you can see, it's only worth 2 marks. There's not much that has to be done here. So it's a question that requires thinking, not a lot of computation. It says here, hence determine the values of c for which the equation x plus c minus x plus c plus 3 all squared plus 4 x plus c plus 5 is 1 negative and 1 positive root. So what you have to know here is, what does x plus c on both sides here mean? Because that's the only difference between what we have here and this equation that we just solved here, this equation here in 5.3. What does x plus c mean? So if you have an equation h of x plus a, let me say plus or minus a, what that does is it shifts your function right or left. Your function right or left. So you have to know now what kind of shifts occur when you have a function, when you translate a function in that manner. So you have x plus c here and x plus c there. Let's just copy that down, rewrite it here. Minus x plus c minus minus x plus c plus 3 all squared plus 5, was it plus 5? Plus 4 plus 4, this should be equal to x plus 5, x plus c plus 5, x plus c plus 5. Now your function here has two roots, a and b. What they are asking is, how can we shift this function such that a is this side of the negative and b is on the positive side, crossing this axis here? So if you're shifting this function, how many units should you shift it to the right such that your b is positive but your a remains negative? What range of c can you how can you shift that function? So you can see that b here is at minus 2. So in order to have a negative b, you should be shifting right at least 2 units. At least 2 units to the right. 2 units to the right. Now you want a to remain negative because the question says 1 negative and 1 positive root. You want a to remain negative. So you don't want minus 5 crossing the y-axis here. And how does minus 5 cross the y-axis? If you shift a more than 5 units, 5 units here, it says it's at minus 5, more than 5 units to the right. If you shift a more than 5 units to the right, then you will have a positive a, and we do not want that. So how do we shift the function then? What value of c should we put in there? It's a bit counterintuitive, but it's simple to remember. When you are shifting a function to the right, you add a negative. When you're shifting a function to the left, we add a positive. So what we have there, you want c to be greater than or less than something. You want c to be greater than minus 5 but less than minus 2. Why? Because if you shift the function more than at less than 2 units to the right, you will not have a positive p. If you shift the function more than 5 units to the right, you will not have a negative a. So this is our range for the function c, for the value c. And just to address the negative shifting to the right and the positive shifting to the right, think of it this way. So if I have a function x plus a, or say, let me say x plus 2, x minus 2, I mean, x minus 2, f of x is equal to x minus 2. If I have a function f of x is equal to x minus 2, if I put in 2 for x there, my f of x becomes, let me say, f of 2. It becomes 2 minus 2, that's 0, right? That's 0. F of 2 is 0. So if I change my function now, say it becomes f of x plus 1. F of x plus 1 will be x plus 1 minus 2, right? That's my new f of x. That's my new function, I mean. What has this done to my function? This has changed my function to x minus 1. X minus 1. So in order to get the same value that I got in the previous function, 0, now instead I have to input 1 there instead of 2. So you can see that there's been a shift to the function to the left because I added onto x. This, however, is a story for another day. Let's continue answering the question. This video is long now. I think I'll just cut it here and continue on the next one just to solve 5.5.